binned age. With this, these are the values in this column, and each row will get the relevant value. Then I created the violin plot and also the box plot. I will show you why in a second. Because the violin is useless. Huh? Okay. I iterate over all columns, and I did it in the reverse order because the first column in my order, the violin graph are not so good. That's why I plotted the box plot also. So I'm getting the violins and the box plot for each feature against the bins of the age. And this is a split violin that you have the violin of two separate groups. In this case, male and female.
Can you explain again how to read the violin?
Okay, the violin, first of all, had two features. Okay, each violin have, in this case, a bin of age. This is 0 to 10, and age. Now I'm taking each one of the groups, and I'm calculating the KD, kernel density estimation, some smooth line on the distribution. Okay, taking a small interval and calculating, we can say, the linear line over there and connect all the lines. It's not exactly the process, but we can say that this is a process. Okay, so we have KDE for each group according to this variable in this bin. Okay, I'm taking all the data point between 10 to 20 of female and calculating the KD. Okay, the KD is like a plot, distribution plot of Seaborn, and say KD equal true. We'll get the same graph but horizontal.
Where's KD?
So in this case, we
Kernel density estimation. It's some fit for the data. Taking small interval and fit.
So, for example, here if I take age 0 to 10, female most likely will get, I don't see, it's 10. What are the
1.
The mode is
1?
in
This is
1.
Yeah. So 1 will be the mode. Yeah, the mode will be 1.
Sometimes violin is not so good.
No, I'm just trying to understand how.
That's why
if I see a violin,
that's why I put the box plot near this graph in order to understand.
But you can add the IQR within the violin. If you have, there is an option to have this information within the violin itself.
Okay. So this is the violin and the box plot for each feature, and here you can see that the violin are not so good. Also the box plot.
Yeah, because you split it the age. I mean, if you had only 5 sections, then you will get.
Maybe. Yeah, or correct.
If we decided to do less.
Let's bin. Okay. Any question about? And obviously, you had one more section to ask a question by yourself and answer it. Any question about question 2? Okay, log normal. So we have two distributions of log normal. You need to remember that log normal, the parameter of the distribution, are the parameter of the underlying normal distribution. Okay, this 0 and 0.25 are the mean and the standard deviation of the underlying normal distribution.
The standard deviation or the variance?
It depends on the definition, but that's why we said that this is the standard deviation.
So it was confusing because the definition for this type of writing is sigma square. And when you say sigma, it's just saying that, okay, this is the sigma, which is here in sigma square,
So,
from the normal distribution of the...
so I don't think it's confusing here. Maybe if you're going to Python and you see how Python implemented it, it will be a bit confused, but I won't reduce any point if you use sigma square and not sigma. But in the exam, read the instruction.
Yeah, the standard sheet is just sigma. It doesn't
Sigma
say,
is standard deviation.
yeah, it doesn't say that it's not square. It's just saying that the sigma is of the...
No, but when you do it normal and put
זה לא
like
נכון.
that, usually you put the
Square,
sigma
yeah.
square, not the
It's
sigma.
a wrong way.
Once again,
No?
בטח.
you put the definition that you wrote. Okay, I wrote that the numbers are the mean and the standard
It
deviation.
doesn't say that. It says that the sigma is from the normal distribution of the z, but it doesn't say it's not square.
It was very confusing because even
Okay, I won't reduce any point. Okay, but, okay. So draw a plot. So this is a plot. Okay, of the two distribution with the standard deviation. Okay, if you use variance and not standard deviation, one of the distribution will stay the same. Okay, the red one, because the standard deviation is 1 and
Yeah.
the variance is also 1. And this will be a bit different. What is
הפוך.
לא משנה, זה בסדר, התכוונת לנכון. The
The
first
blue
one is
one
square.
is the standard
Yeah.
normal, and the red is the non-standard.
The first one is 0.25 sigma.
אפשר לראות גם לפי
אוקיי.
תוצאות.
okay? What is expected value? How can I calculate the expected value of the log normal?
x of mu plus sigma squared.
And a better way to do it?
That's log normal.
So I can use, first of all, the mean of the distribution. Okay, what is the mean of the distribution? I took two distribution. Okay, I define two distribution, and I can ask about what is the mean. And also I can calculate it according to this formula here, e in the power of mu plus sigma square over 2. Okay, and you can see in the formula sheet that we uploaded to Moodle that you have some of the formula. Okay, you don't need to know those formula by yourself, but you need to understand what formula you have in the formula sheet and which formula you don't have in the formula sheet.
But you can also use the stat log norm to get the
This is the stat log norm.
הוא פשוט בנה לעצמו את ה... מה שאת אומרת.
אוקיי.
What is the probability of y1 being more than 4 standard deviation larger than its mean? What will be the process to calculate it?
To make 1 minus CDF of the log normal.
Okay. 1 minus CDF of the mean and the standard deviation of the distribution. Not the mean of the standard deviation of the underlying normal distribution.
Yeah.
Okay. What is the probability of y is the same, y2. And the IQR, two ways to calculate the IQR, two Python ways, actually.
NP.IQR, no?
So we have the stats.IQR. Sorry, we have the PPF. Okay, if you can do NP IQR, but then you need data. Okay, in order to do NP.IQR, you need data. So you need to take a sample of the data. But I don't want to use sample. I want to use the distribution. So I can use the PPF, 0.75 minus 0.25, And what else I can do?
You can use interval.
I can use the interval function, okay, with the size of the interval around the mean
טוב.
or the median.
No.
רק יואב דיסטינקט.
What do you do right now?
תעשה את משהו אחר.
I use another function of SciPy stat that calculating the IQR for me.
And why have 0.5 here?
Because this is the size of the interval. 50% of the data, the center data. And you can see that this is the same.
הבנתי, ועוד 25 ו-6.
Eh,
1.5 for both sides. 1.5 for both sides.
It's the total size of the
So
interval.
it's 25% that way and this one.
But you can read the documentation.
I have a question. Actually, it's related to the previous question. It's okay. Can you maybe about log normal in Python? It has 3 parameters, which is a little bit confusing.
Mhm.
And the parameters are
It gives S,
log and
scale.
זה סיגמה, the mu.
Yeah, S is the sigma.
סקייל זה כאילו הנקודה של זה, אם קוראים לזה שייפ, למעשה זה כאילו E בחזקת mu.
scale is
No.
log is a mu.
Yeah.
and
כאילו אתה משפיע על המין של הטובי.
עכשיו רושם לך מה זה סמך.
The S is a sigma
Yeah.
of the
underline.
underlying distribution. And you have here
הסיגמה של
the
הנורמל.
Yeah, I read it.
standard
I
standard form. To shift and or scale the distribution, use log and scale. It's just scale on the. It's multiply each values by this scale, or divide each value by this scale.
מה המשמעות של זה? What is the meaning?
The meaning is that it convert the distribution to standard normal. Okay, if you divide it by the scale, if you're using scale and divide it by the scale, you actually do something like x minus log, which is x minus mu, divided by scale, which is exactly the standard normal if we have normal distribution. And you can use it if you want, but scale, the default value is 1, so you don't have to do it and you can leave it aside. But this
Deviation. Sigma.
this
לא, אבל זה מבלבל, זה לא...
this
זה לא ה-S. It's not the S that you get
it's not
for
the
this.
S, it's not the S,
It's a scale.
it's not the S.
So it's not normalizing the value. I mean,
Normalizing the value according to the scale.
to the scale, which is not the Z what we are talking about, like normal, standard normal. It's something else.
But
You can use it to scale the values, but it's not scaling it to the standard normal.
You can scale it to the standard normal.
If you
But you can scale it
place
to
the
different.
sigma.
But you can scale it to different
Yeah.
values.